Hi, this is Mark Newman from Precision Analytical. We recently sent out a video with a hormone riddle for you to contemplate, and I'm making this follow-up video, and I may have one more because this is a pretty complex topic, to kind of explain the answer to the riddle, at least as I see it. At Dutch Test, we are having lots of conversations about how to monitor hormones well, both with and without HRT. And this conversation is going to dive into a pretty confusing topic on, no pun intended, topical hormones in terms of just how do we monitor them and what to make of this data. So I encourage you to watch the other video if you didn't see that one, to see the question sort of laid out. But just in short, we know when we add transdermal hormone therapy, particularly progesterone, we see a much higher response in saliva than we get in serum. So we looked at this a little bit in our last video and showed that the response you get in serum is about 1/10 of luteal when you use a physiological dose, the dose that a woman makes during the luteal phase. And in saliva, you end up 100 times what you have in the luteal phase, this massive response in the saliva gland of hormone when it's applied to the skin. So we looked at all the studies and say, hey, if you look at all these studies, none of them are getting progesterone up into the luteal range, and it really doesn't scale up with dosing. And we contrasted that with testosterone. So progesterone acts uniquely and differently than testosterone, at least in serum, in that in serum, testosterone moves up and scales up as your dose goes up, and you can get men into their normal range, whereas with progesterone, the serum values don't really seem to budge. And when we looked at the math, we saw the saliva values approximate or show us that there seems to be 1,000% absorption, which just doesn't make a lot of sense in terms of what's going on. But the serum values don't seem to budge either. And we want to answer this and figure out what seems to be going on in this situation. So why, when I put hormones on the skin, do we get a massively higher response in saliva compared to either a serum sample or a urine sample? And these were some of the questions that we were asking and wanted to explain, and we're going to do so now. How can we explain this wild difference between saliva and serum and urine values? So it's not explained by free hormone. Some people intuitively say, well, saliva is free hormone, serum shows your total, but free hormone, especially with testosterone, can be measured in serum. And as the dose scales up of transdermal testosterone, the total hormone goes up a little bit. Again, the saliva goes way up. And the free hormone that you can monitor in serum goes up to the same degree as the total hormone in serum. So that doesn't explain this massive increase in saliva. When we look at the data we're going to see today, we're going to see that the data does not imply that saliva is representing all tissue. It's a unique response that we see in saliva. And my explanation would be this, that this paradox is best explained as saliva having special access somehow to fat-stored hormones, and serum or urine are going to better represent systemic tissue exposure. We also ask, does the skin really allow better absorption than vascular tissue like vaginal application? Because the saliva numbers seem to imply that the skin allows about 10 times more hormone through than vascular tissue as in vaginal application. And that doesn't make a lot of sense. The skin is meant to be a barrier much more so than vascular tissue. And which sample, if any, best represents systemic tissue absorption with transdermal application, and what clinical data aligns with the testing? So when we look at this here in a minute, what we're going to find is that for estrogen patches, saliva, serum, and urine seem to tell a fairly similar story. But when you get to gels and creams, that's where you see this separation, where the salivary response is much, much higher. And serum and urine patterns align best with the clinical data. That's what we're going to go through real quickly to look at what the studies say and to overlay that with these responses, these differing responses. And what we're going to show is that the clinical response seems to move as the serum and the urine move. Now, we want to be careful with that interpretation with gels and especially with creams, because there can be a pretty fast up and down pattern. So if you have a fast up and down pattern with serum, it's going to be hard to capture that. Whereas urine might be a better option, particularly for estrogen gels and creams, because it's going to capture the hormone levels over time. And just as a reminder, there are a lot of people using compounded products, and that can be fine, but there are no interventional studies for compounded creams that we can use in this argument. So that's important to remember. So this is my interpretation of what's going on when we're using transdermal hormones. So what we're trying to do is drive the hormone through the skin and into systemic circulation. Now, once it gets there, you should get a fairly equal representation from urine, from serum, and saliva. So some of the hormone is going to be bound to the binding protein, and actually most of it. Now, some of the hormone in its free form is going to get to the liver, and the liver is going to make it into its water-soluble part. That is the glucuronide or the sulfate. So that's a conjugate. That water-soluble conjugate ends up in urine. So urine gets its representative amount. And then the protein-bound and the free hormone are going to end up in saliva or serum. So in serum, urine, and saliva, we're measuring hormones in their different form. But if we drive it into systemic circulation, we should see a representative amount in each of those body fluids. Now, a lot of that hormone, as it penetrates the skin, this is my interpretation of what the data seems to imply. I think this is an oversimplification, but I think it's a helpful model because it seems to align with the data that we see. Now, that hormone's not getting into systemic circulation, but somehow it's able to migrate through either subcutaneous fat, maybe there's some lymphatic transport involved, but it seems to move in what might be better described as some sort of diffusion and ends up in the saliva gland, into the saliva, and therefore the saliva is an overrepresentation of what's going on systemically, and those fat cells remain loaded up with hormone. Now, what data would imply that this is maybe what's going on? Well, one, here's a published study. Now, it's an old study, but this has been replicated in a lot of clinical cases. In this case, what they found is when they gave women transdermal progesterone, they looked in saliva, they got really big numbers, just like we've seen. Then they stopped giving transdermal progesterone, and they continued to see those elevated numbers for more than 12 weeks, right? Which is consistent with a model of fat-stored hormones slowly leaching out of the fat and being expressed into the saliva somehow, whereas it's not seen in the urine or the serum. I've actually seen a fair amount of clinical data from women who have been on transdermal progesterone and then off of it for up to 6-7 months, where the salivary values are still elevated. And I don't think we would probably assume that the endometrium and the breast tissue remains loaded with hormone for months and months after the cessation of therapy. It seems to be more consistent with this model of the hormone loading up in the fat and the saliva gland having special access to that. Another set of data, and this is just from one person's personal experiments, and thanks to Dr. Gilson for sharing that, but where we've got hormone put close to the saliva gland, and then as it gets further away from the saliva gland, you can see that you get lower numbers. Now, don't miss the scale there that's logarithmic. So the values that are put very close to the saliva gland give you huge values in the saliva, and then as you move further away, while that number is still very big, it goes down, which again implies that maybe that hormone is diffusing into the saliva gland somehow. And anyone who's ever used a facial cream with hormone and then done a saliva test has certainly experienced this, because you get this very high number, and it's probably best to assume that that doesn't represent what's going on in all of the tissue that we have. So the saliva response greatly exceeds serum or urine, but it seems like we can make some clinical sense out of the data for estradiol and testosterone. So I want to look through that data, but it brings me to this key point. I don't think you can properly understand this issue and appreciate this issue and make sense of it unless you treat progesterone differently than testosterone and estradiol. Progesterone is the most lipophilic of the hormones that we're discussing. So any sort of dichotomy that's caused by fat solubility is going to be most extreme in progesterone, and in fact, it is. So the progesterone that's hanging out in the fat cells or wherever it's stored for months and months after the cessation of therapy, we don't see that with the other hormones, and it's much harder to drive it into systemic circulation compared to testosterone and estradiol. So what that means is whatever we can prove to be true about progesterone is not necessarily true of testosterone and estradiol. They need to stand on their own with their own data. So the serum and urine responds to increasing doses of testosterone and estradiol much more than progesterone. Now let me show you that this is true. In urine, when we look at creams and gels, this is estradiol. So here's your baseline postmenopausal woman, and as we give hormone, it scales up. We expect to see that, right? But look what happens when we use progesterone. When we use progesterone, that value, when you move from 20 milligrams all the way up to 200, doesn't scale like the estrogen does. So when we compare those two, it's a pretty different response. Now, saliva testing, and we're not going to talk a lot about blood spot testing, but it follows this same trend, that they both correlate to serum testing when you're not on therapy. But when you use transdermal therapy by way of creams and gels, they have this very exaggerated response where these doses, you'll remember 50 milligrams puts you in the middle in serum, the middle of the normal range for serum, but with blood spot and with saliva, it puts you way outside of it. So then that leads us to this big question, which has been a lot of conjecture and a lot of opinions on, is the salivary and blood spot response greatly exceeds the response in serum or urine. So which one is right? Like, how do we know which one properly represents systemic exposure or tissue exposure? And the way that we want to investigate that is to ask the clinical data that's available. Now, just as an aside, what we can't do is ask the patient. And what I mean by that, we cannot base this on anecdotal evidence that says, hey, did the patient get better, right? So if you look at this data, this is hot flash data, and you can see over 12 weeks that the hot flashes subsided significantly, right? But this is the placebo arm of the study. So most of these women are saying, yeah, I feel better, but this is the placebo arm. So we can't just rely on anecdotal evidence. We have to look at some of these placebo-controlled studies that can give us better insight into that. So let's look at them. First, for estradiol. Now, just as a reminder of what this data looks like, when you use estrogen creams, 24 hours after therapy, which is right before your next application, so this is as low as the values should get, even a low dose like 0.3 is going to put you above the premenopausal range. That's a 24 hours. 12 hours, you're going to be more like 10. So you're spending the entirety of your day in a super physiological state, and that's just with 0.3. At 0.5, you're even higher. So that looks like an awful lot of hormone for estradiol. Now, when we look at the same types of dosages and we look at urine values, we're not above the premenopausal range. We're out of the postmenopausal range, but we haven't yet approached the premenopausal range unless we use higher doses around 1 milligram or so. Right? So that's a contrast there. And then what we do is we go to the clinical data and say, okay, what does the clinical data say? Well, we can find a series of papers that if you dig them out and read them, what you'll find is that the bone mineral density seems to move along with the serum data. So this is estrogel data in serum. Okay, so remember, a dose of 0.75 is really high in saliva, and in serum, 0.75 is moderate, right? It's just out of the postmenopausal range. So when you look at the bone mineral density data on this exact product, what you find is that at this dose right here, the bone mineral density improves 6 months after you start the therapy, and it's still better 12 months after the therapy. But when you step it down a dose to 0.75, what you find is at 12 months, the bone mineral density is improved, but not at 6 months, right? So it's just barely working. So if you use a low dose patch, like 0.025, which is a low dose, you're going to see bone mineral density improvement at 6 months and 12 months. With gel data, again, the 0.75, which is barely moving the serum, is barely working in terms of the clinical impact. So that's really important because it aligns with what the story that the serum testing is telling us, right? So if you use 0.75, you're somewhere up in this range. So that says, wow, that's a lot of estrogen. It certainly should be more impactful than a low dose patch, a low dose of estrogen, but in fact, the clinical data aligns better with the serum and the urine. Okay, vasomotor symptoms. These studies here show that at these doses that just begin to move the serum up and out of the postmenopausal range, or the urine up and out of the postmenopausal range, they don't work as well as something like a low dose patch. And with a higher dose, they will work. Whereas a salivary value would assume that this is a lot of estrogen, these 0.3 and 0.5 milligram doses, but they don't work as well as higher doses or low dose patches. Again, the clinical data seems to overlay more consistently with the serum data than it does with the saliva data. And on the other side of this issue, I haven't been able to find any studies that say, hey, the serum value hasn't moved here, but wow, the hot flashes got tremendously better compared to placebo, right? That's what we're looking for. Same thing with vaginal atrophy. I don't see any studies that imply that the serum value is wrong. And when we look back at this estrogel data, this dose worked better than placebo for vaginal atrophy, as did these two doses. But when we look at the dose that is not yet out of the postmenopausal range, guess what? It failed. The vaginal atrophy did not improve. But again, with saliva testing, it tells us that that dose is a really high dose of hormone. We wouldn't expect it to fail. So the clinical data, again, overlays much more consistently with the serum and the urine data. Now, for testosterone, there's a lot of data. And testosterone data provides us a really good opportunity to look at this, because we look at this data in saliva on the left, serum on the right. We say, look, when we use 50 milligrams, we're right in the middle of the normal range for males in serum, and we are way outside of it for saliva. So it provides us a really good opportunity to ask the question, is that 50 milligram dose behaving as a supraphysiological dose or as a modest dose? And all of the studies that I can find seem to fall in alignment with the serum response. So for example, erythrocytosis, LH suppression, muscle mass increase. Let me look at these real careful. Erythrocytosis, a 50 milligram gel increases erythrocytosis 5 times less than a typical injection, meaning the injection that people have just typically used increases erythrocytosis quite a lot. The saliva value on that 50 milligram gel would imply that that's even more hormone than the injection. We would expect erythrocytosis to also be very significant, but it's less than the injection. Why is that? Likely because the saliva value is not actually representing systemic exposure. Same thing with LH suppression. If I look at a hypogonadal man, so a man with low testosterone, generally their LH is a little bit high. If you give those men a really big injection, their LH will go to 0. If you give them a modest dose of LH, it'll slide back into the normal range, and it won't go that low. Well, when you use a 50 milligram gel, it decreases LH moderately down into the normal range. If the saliva value is right, and this is a really, really big dose of testosterone, then you'd expect the brain to say, wow, we need to hold off on LH production, and that's not what we see. It's more consistent with serum. This is a really nice study that Sattler did where they actually suppressed endogenous production of testosterone. But before they did that, they looked at muscle mass. And then they gave men 50 to 100 milligrams of transdermal testosterone. Then they split them into groups, and they said, okay, whose serum value is higher than it was before the study? Whose serum value is lower than it was before the study? They only saw muscle mass increase in those people for which the serum was higher than before the study. Now, keep in mind with this study, 50 to 100 milligrams of testosterone is going to push the saliva value in 80 or 90% of men, way higher than a physiological level, which would tell you that must be plenty of testosterone to build muscle mass increase. But the muscle mass increase isn't there unless the serum is actually moving. Again, the serum is more consistent with what we find. Now, here's a study that looks at it from a negative angle. They used 100 milligrams, which sounds like a lot, yet it failed. They didn't see an improvement on bone mineral density, sexual function, and the things that are normally seen with appropriate testosterone therapy. But the serum didn't go up. Usually, serum will go up about 250 nanograms per deciliter with that dose, and normally you see bone mineral density, sexual function, etc., improving. In this case, the serum only went up 77, which is a lot less, which implies that it didn't really absorb very well, therefore showing that serum, again, is representing what's going on systemically more so than saliva. 80% of men on 100 milligrams are higher than 1,000. That's 10 times normal. So how would then 100 milligrams be insufficient to see clinical impact? Probably because serum is better representing what's going on with testosterone. So all of these studies really align with the clinical data moving as the serum moves. The urine tends to parallel serum. So those two are more aligning with the clinical data. And to date, I can't find any studies that say, hey, we used, let's say, 10 milligrams of testosterone or 5 milligrams, and we got this massive clinical improvement, but the serum didn't move. I don't find any studies like that in the literature. If we look in women, we can see a couple other examples. A couple authors have used 10 to 30 milligrams of testosterone gel and report no symptoms of high testosterone in women. Now, if 10 to 30 milligrams is really actually a pretty high dose for men, which is what saliva would imply, then we'd expect to see facial hair growth and acne and things like that in these women that are using 10 to 30 milligrams, and we don't. On the other hand, in a study where they were looking for testosterone to actually cause these symptoms, so these were transsexual males that were taking testosterone with the intent of increasing facial hair and those sorts of symptoms, they saw the symptoms they wanted with 50 milligrams a day, and guess what happened to the serum? It went up into the normal male range. So the serum, again, is moving along with the clinical picture. Here's some data from a saliva lab where they actually looked at symptoms like facial hair growth, and they simply asked the question, as we use topical testosterone, so everyone in this informal study here is on transdermal testosterone and did a saliva test. Each one of these data points represents hundreds of patients, and the women who were clear pushed out to 250, which is about the same number you get from a man using 5 milligrams of testosterone, they didn't see increased symptoms in that group, which again tells you that what ends up spilling into the saliva doesn't seem to be getting into the tissue that really matter when it comes to testosterone. But we remember, testosterone and estradiol behave differently than progesterone. But for testosterone and estradiol, the clinical picture seems to move in concordance with serum, not with saliva. Now, what about the studies on progesterone? Now, here's where you've got a legitimately mixed bag when you look at the studies. If you're talking about the endometrium, Leonetti's done studies that show that it seemed to protect the endometrium when you used it transdermally, whereas Wren and some other authors have looked at this same variable, and their studies actually contradicted this and said, look, we used transdermal progesterone. In the case of Wren, they even saw elevated salivary values. All of them show low serum values, and the authors on the left found no endometrial protection. Leonetti found that there was. So maybe there's some room for some investigation into progesterone further to see under what circumstances it may actually protect the endometrium. Now, what about hot flashes? Progesterone is known to help with hot flashes. Wren, again, and Benster, who had the largest study of this type, found that no, when we used topical progesterone, it didn't help. Leonetti, again, found that it did. So again, some conflicting data in the literature. So when we look at this huge contrast between serum and saliva, when we take transdermal hormones, there might be a little bit more to tease out of the data when it comes to progesterone. But for estradiol and testosterone, I think the jury is no longer out in terms of which sample types seem to best reflect what's going on systemically. So I hope that helps you to understand this complex data a little bit better, that we need to separate progesterone from the other hormones, and we need to look at this route of administration with a lot of care to understand how to best treat our patients and then how to monitor those patients while they're on this type of therapy. The last question that we asked, since we started with progesterone, is this practical question of, is there sufficient data to know if transdermal progesterone really protects the endometrium for women who are on estrogen therapy. Again, Leonetti's study said yes. Multiple other studies contradicted that and said no. So there isn't sufficient evidence that it protects the endometrium. Perhaps we'll discover down the road the manner in which it must be given transdermally in order for that to work. But as of now, if you're going to go with the data really suggests that oral progesterone is going to do a good job. There's limited data, but it seems to imply that vaginal progesterone also protects the endometrium. And with progesterone that's given transdermally, there really just isn't enough data to confidently use it and know that the endometrium is being protected. So I hope this helps you to understand this complex situation a little bit more. We'll be having additional videos to further explain some different aspects of this. But if you have any questions or some feedback on this topic, feel free to email me at mnewman@dutchtest.com, and we will continue to share relevant information like this as it becomes available. So thank you for your time, and hope you're all staying safe.